So last section, 8.4, we've been doing difference of means pretty much all chapter. Either they're independent, dependent, large sample, small sample, all that good stuff. But now we are going to do the proportions, and we derived kind of the Z formula here the other day. Basically, remember, statistic minus parameter, and then standard error is basically where that comes in. And this is just an average of the percentages right there. So not too hard there. Remember, the test statistic itself is just p hat 1 minus p hat 2. That's what you found out from your sample. And then we have to standardize it so that we have something to actually compare it to. Otherwise, we can't necessarily compare one problem to the next. So let's keep those formulas in mind as we do this one here. So there's a study of 200 females and 250 males, and they happen to use the internet. 30% of the females and 38% of the males said that they plan to shop online at least once during the next month. Well, maybe that's probably all right. Maybe a little bit more than that now. So at a level of significance of, what, 10%, test the claim that there is a difference in the proportion of females versus males. So we're going to test that we think there is actually a difference. So what do you think, 30% versus 38? Do you think, is that going to be enough to show off an actual difference there? Might be, right? Because it's 200, 250. Well, let's find out. You know, it might be. You know, if it was 30 and 32, you know, we'd be like, probably not, right? But 30 and 38, well, maybe. All right, so let's find out. So let's start with, got to be everybody's favorite by now, null and alternate. And so what are they saying here? They're saying that there is a difference. So in other words, they're saying that, how are those two related? Basically, that's what they're saying, right? That's their claim, that there is a difference, so they are not equal. So the claim is down here, so then this one must be that they are equal. And let's say that the first sample is the females and the second sample is the males, so that we're all talking the same language here. Remember, that takes care of itself if you do it the other way. And so what are we looking at here? Right-tailed, left-tailed, two-tailed, what? Yeah, two-tailed, right? So let's make a note of that. So two-tailed, so that we know. And you notice I haven't been graphing them as much because I think you probably almost have a mental graph at this point of what that is. You don't need to see it anymore because I've done it so much. You've seen that. And, well, if we're going to test this thing, we should probably find some kind of critical value, right? That we can actually find and test versus our standardized. Do you happen to remember this one? It's been a while. Okay. If not, why don't you look it up in your tables to make sure that you remember how. Remember, 10% is the total, right? And so it's 5% on each tail. And so what does that end up? So if it's 5% on each tail, it's 90% in the middle, right? And 90% is the smallest of them, right, that we had. Now you're just rattling numbers. The 1.6 was good. No? 1.645. Very good. And positive and negative, of course, because it could fail either direction. I think we have a pretty good idea of which way this one's going to try and go. Now, we could get started on the z-score right away. We could do that. But because the top of the z-score is quite simple, right? The top is just basically the difference in our proportions right here minus, and we're going to say 0, right? So, but what I would like to probably do first is let's go find those two things so that we can just kind of write it all out as one, okay, instead of sitting here and doing it separately. So let's go find out that first. So P bar is, well, we kind of have to average these out. Now, here's where it gets a little tricky if you're not good at math, because we need to know x1 and x2. How do you find that? How do you find x1 and x2? Let's maybe make a little note over here of what they are, because these are the important things, right? Well, n1 we know is 200, and n2 is 250, because I believe we agreed that this was going to be the guys, right? And this was going to be the ladies. So yeah, what are we going to do? Yeah, we know that 200 were, and we know 30% of them said that they would, right? So you take 0.3 times 200, This really shouldn't be much of a surprise on that one. Yeah, hopefully you can do that one on your own, right? 60, right? And then the other one is going to be 38% of the 250, which is 95. Okay, so now let's go ahead and find the P bar. And so we take 60, because that's how many females, plus the 95, right? Over, I think we can add those other two by ourselves, right? 450. Good job, John. So let's find out what the average is. So, well, why don't we just go approximately then, 0.344, I believe, right? And how do we find the Q bar again then? Yeah, 1 minus that, right? And so 0.656, right? Everybody good with that? Right? Some of you are looking at it kind of strange. That's why I'm taking a break there for a second. All right, so let's go and get our actual Z standardized test score. So we take P hat 1, which is what the females, right, which was 30%, right? So 30% minus the P hat 2, which is the guys on this one. And we're going to say that the difference of the actual population proportions is 0. Divided by big old square root. Because remember, on top is the statistic minus the parameter, and on the bottom is your standard error. So then, yeah, I was going to say we should kind of have some idea of which way this is going to try and fail, possibly, right? So then you take P bar times Q bar, and then 1 over 200, I believe, is the first one, right? Can't quite see it on my screen right now, but it is up there, 200. If I were you doing the calculator, I would take care of the bottom first, all right? And so I would probably type something similar to this if I was trying to do it. I would say, all right, let's go 0.344 times 0.656, and probably just find out what that is, especially if you're a little uncomfortable with the calculator, right? So I've got these first two then taken care of, and then times, and then put a parenthesis, 1 over 200 plus 1 over 250. Okay. Is that the denominator? Yeah, still got to take the square root. Very good. So square root of that. Boom. Now, of course, we could write down that decimal, but if we're very clever, we don't have to. Well, let's face it, we should probably be able to figure out the top without actually typing it in, right? But let's say it was one that it's a little iffy and we didn't want to. You could just go ahead and do this and say 0.3 minus 0.38, close it off, and then divide by the answer, right? Again, we all know that one, but let's say it was a little bit harder one or something like that. So what is this now? What would you call this? If somebody were to ask you what to call that particular number. Very good. The standardized test statistic so that I can compare it to other tests out there or other proportions out there. Otherwise, we're not necessarily comparing the same thing, but now we are comparing it to the same thing. And so now we've got negative 1.775, we'll say. So this is approximately negative 1.775. Is that what I just said? Okay. So what does that mean then? Well, we have to compare it to this, right? And again, you have a pretty good picture of this by now, right? We know here's our rejection region at, well, negative 1.645 is the one we're concerned with. And according to ours, we ended up in here. Okay, so we are in the rejection region. So the null gets rejected at 10% level of significance, remember. That's important. Because let's face it, if we move this level of significance, we probably don't have to move it very much to make it that's not in the rejection region, right? that we are able to support the claim. So they say there is a difference. So that might have ended up closer than you thought. When it was 30% versus 38%, okay, so it ended up probably a little bit different than you thought. But again, we were only talking about 200 and 250, so at that point, think, that's good, but it's a lot. But okay, so any questions on that? No? All right, so let's do the next one, and then I will show you that the calculator can actually handle these, of course. So a research team has a study to test the effects of cholesterol reducing medication. At the end of the study, they found that, wow, of the 4,700 subjects who took the medicine, 301 of them died of heart disease. And of the 4,300 subjects who took the placebo, everybody is familiar with the word placebo, correct? Meaning it had no medicine, it was probably a sugar pill. 357 of them died of heart disease. Now look at the level of significance this time. Very small, so 1% level of significance. Can we conclude that the death rate is lower for those who took the medication? Yes. Whenever you do a study, you have to have what's called a control group. And normally it's normally a double-blind control group, so that the people giving the medicine don't know who's getting what, and the people taking it don't know who's getting what. Yeah, you would have to sign off on this study. And I do believe this is an actual study that was actually done. Okay, yeah, it doesn't seem like it at this point, right? It really seems, but you got to realize it's 301 out of 4,700 and 357 out of 4,300. So do you think that the medicine was helping? And this is how they actually find out. Well, in a way, this is how they figured out, is this helping or not? Okay. And so we're going pretty accurate here, right? We're saying, does it or not? And so everybody's favorite. And so, well, we know we're talking about the two percentages, right? We're going to relate them somehow. And we should probably, again, talk the same language. So we'll say that sample 1 is the ones that took the medication, okay? And sample 2 will be the ones that had the placebo. And so where's the claim here? It says, well, can you conclude that the death rate is lower for those who took the medication? Yep, P1 less than P2, and so our claim is, because we'd like to support that, right? We'd like to say, yeah, that is true. And so you see just how that question was asked allows us to put it down there to support it, right? And so then the other one is greater than or equal to, so we are looking at a what tail? Left-tailed, all right? That's the beauty of that alternate, just points to it, right? And we better probably have some critical. Let's see if you remember that. So we know it's negative, right? Is it? If it's one-tailed and you're going that far out. Isn't that one-tailed, isn't that a two-tailed, that 1% is 2.575? Because then you have 99 in the middle. You've seen this number, but maybe not as much as the 2.575. It would have to be less than your
2.4.
Negative 2.33. Again, you could look that up, and if you're unsure, maybe try a few, and because we haven't done this in a while, actually looking those up. So make sure that you can instead of memorizing them. You already just get them wrong. All right, so over here, this is kind of how I do it. I actually do write this down when I do it. And there are times that I'll even say, give myself a note that, oh yeah, this is, maybe the placebo. Whoa, spell it right though. And this one here is that they took the drug. So X1 is, and we're going to say our proportion here, you could do it either way, right? You could do the percent that lived or percent that died, but percent that died is a smaller, so we'll do that one. So 301 over 4,700. And one thing we haven't checked on either one of these is that, N1 times, all those work out, N1 times P, N2 times Q, all that stuff. But this is out of 4,000, and the other one was out of 200, so I think we're probably okay. We don't actually have to check those to make sure they're more than 5. And then the other one is, what, 357 out of 4,300. All right, so we've got that. Yeah, I'd say P bar. Well, yeah, we can figure out P hat if you want. We're gonna have to do it eventually, right? We're gonna have to do P hat 1. We're gonna have to do P hat 2, and we're gonna have to do P bar and Q bar. Because this time I didn't give you the percentage, but how are we gonna do it this time? So I notice I did give it to you a little bit different. Well, we're gonna take 301 and divide by 4,700, and we get is it 0.064? Yeah, so it's 6.4%, right? So that's 0.064, right? And then how about the second one, P hat 2? And I like how I'm starting to be able to say them this way, and you know what I'm. So I lost it. 0.083, you said? I agree with that. That's what I had. So 8.3%. So at first glance, it didn't seem like much, and it really isn't. It's 6.4% to 8.3%, but that's of a lot of people, right? So maybe it is enough when it's that many people. So let's go ahead and work on these. So here for this, we're going to take 301 plus the 357 out of, again, hopefully you can kind of add those without doing it, right? 4,700 and 4,300 is big number, 9,000, right? And then I wrote 900 for whatever reason. So 0.073, you said? Does that seem like a decent average? Because they were both, one was out of 4,300 and one was out of 4,700. So neither one was going to carry a whole lot of weight into that average, right? So that seems about the average between the two percentages we just got, right? That seems pretty good. It's a weighted average, which is what we should do. So Q bar. Pretty high then, huh? .927, right? So at least on average, 93% of them lived. That's good, right? Sometimes it's helpful to just sit there and say, what does that mean, right? On average, 93% of them made it over the two tests. All right, so we have a lot of numbers here. There's all over the place. Yeah, exactly. Now let's use them. All right, so we've got to go, what's this again? Standardized test statistic. Very good. And so we're going to take our sample, which, I can't see it anymore. All right, let's 0.064, right? Minus 0.083. And we're going to say again that the actual population has a difference of nothing. Over. Now what if I actually just subtract those two? What's that called? The 0.064 minus the 0.083. Yeah, that's just your test statistic. That would say that one is lower than the other, right? And so now we got to find our standard error. And we've got 0.073 times 0.927. And then 1 over 4,000, was it 700, I think? And 1 over 4,300. Okay. And I showed you the calculator first time, so I think you can probably handle working that one out. We'll give you a second to do that, and then we'll see if the calculator just doing the problem for us also agrees. And I think we did note that it seemed pretty close when we started, right? I mean, it seemed that the rates weren't too far off. So we were kind of thinking that maybe the drug was really not helping enough, right? That's kind of what we concluded before we even got too far. So this z-score may surprise you a little bit. That's what I got, negative 3.46. So why is that so far out? Because the percentages, I think I got a 1 after that or something like that. Why is that so far out? It's a very small percentage, but it's 9,000 people, right? So that makes a big difference. Because look at how much you're dividing by there. Because really think of it this way, yeah, you're dividing by that number down here, but really you're, in a way, kind of multiplying by that, right? And so negative 3.46 allows us to reject the null, which allows us to support the claim in this study. And again, at 1% level of significance, and look at this, it didn't even come close, right? It's not even close to maybe being rejected or maybe not. According to this, that drug that they are testing there actually is helping. Okay. So I think there is probably one of the first times it's something more real to you. Mm-hmm. And they kind of have to be to get some kind of conclusive result. Yeah, assuming that, yeah, that they didn't do like one gender versus another in the two tests or something like that, that it truly was randomly. But that's what we're assuming here, that all of this stuff was done randomly. There's no, let's put it this way, all of this is based almost in a vacuum, that there's no human error, which, let's face it, they're probably in real time. There is some, that this was randomly done. When you walked in, they sent you to one room or the other, and they just kept kind of, oh, you go there, you go there, oh, you go there, you go, and they just randomly chose these people to go either into the placebo area or into the other one. Exactly. There's always variables that are out of your control. Exactly. Yeah. Well, I mean, let's face it, that maybe these are obviously people that probably have high cholesterol, and they wanted to be part of a study, and they signed off on it, saying, yes, I want to be part of this study. I will do what you say, and I'll come take this medicine every day. I understand that it might be a sugar pill. All right. And I understand that maybe I will get this medication, because they have to test it at some point. What's that? Yeah, I also, I understand that I have high cholesterol, which could make me have heart problems, and so on my own, not because of this, I might not make it. So there's a lot to be understood there. Yeah. So let's see if the calculator can actually do this problem. And basically, all the information you need is over here in the blue. That's all you need. Okay. Well, okay, you do need to know the alternate hypothesis, right? Because they're going to ask you that. And so what do you suppose we're going to go? Where we're going to go? Yeah, so let's go with stat, right? And do a test. And a two-sample, yeah, go to the two proportion z-test, which is number 6, right? Right? Oops, well, went too far. Right there. And so, yeah, this one's pretty slick. So x1, you just type in, well, 301, right? N1 is 4,700. X2 is 357. And N2 is 4,300. And then what do we have here? We have the second one, right? And then again, you can calculate or draw, whatever you want to do. And so let's check Z. Is that what we got for Z, right? That's what we got. Look at P, though. This is very sometimes misleading for people. Some people say, oh, it's 275 probability. What? Yeah, look at the end. It's e to the negative fourth on the P there, which means 0.00027. So that's, less than, very much smaller than alpha. Let's put it that way, right? If I compare that to 0.01 at alpha, that's what you're supposed to do with p-values. It's much smaller, which means it's in the rejection region, right? And here's your p hat and your p hat. See, the calculator, I'm not making the hat thing up, right? And then that number should look familiar, that one at the bottom, 0.073, right? That's your weighted average. So I think a lot of people would prefer that to have a bar over it. But they're still saying that is an estimate because it did come from a sample. But we had to give some different notation to it. And then it just, that was stuff you already knew. So, it's pretty nice. But you still have to know what's going on, because once you get down to that question of, is it less than, is it equal to, not equal, you still need to know what's going on, or you're just going to put something random in there and it might not be right. Okay? And so you still need to know what's happening. So it'll be easy enough to check. Okay? So any questions on today's? So all of this chapter was devoted to testing two samples. A lot of times it was the mean, right? And then sometimes it was, in this case, the proportion. And again, we're not going to touch on variance today because that is almost a complete other chapter dedicated to that. Because let's face it, that's been the hardest part of almost all of these formulas, is that error, that standard deviation. So